This conference will now be recorded.
Hello, SID LA. This is Chris Chenok. I am the president of Insight Media, as well as the executive director of the 8K Association. So I'm going to be talking to you today about 8K, as well as the light field and holographic ecosystems. So let me apologize in advance. This has to be a somewhat high-level summary of these two ecosystems. There's a lot in each of them going on. And I don't have a lot of time, so I'll do the best I can in the time allowed. So here's a quick outline. We'll talk about the ecosystems in these areas. So let's start with 8K. I kind of like this picture because it shows how big a canvas 8K is compared to 4K and HD. It's a lot of pixels, and that creates some opportunity, but also some challenges. So clearly 8K is kind of the next trend in what we've been seeing of resolution transitions over time. And let's not forget, it's not just about more pixels, which is what some people clearly just focus on. These are HDR pixels, so they got wide color gamut and high dynamic range as well for the most part. It's clearly the highest quality capture and display level at this point, although on the capture side, there are cameras that exceed 8K already. And I think most of you would agree when you've seen these next generation displays, technologies with high quality content and production, it's kind of a wow moment. And I think you will, most people would say that for 8K as well. Because it is an almost 3D-like image when done well. And it also provides, on the capture side, a lot of flexibility, even if you're finishing and distributing in lower resolution. So 8K is basically on schedule here, and I base this on this data from, which credits Samsung Display, but it's based on data from Omdia. And this shows that from the introduction of a resolution technology to 50% of sales, it's a pretty consistent 7-year cycle. Now, COVID may have delayed 8K by a year or so, but you know, all of these factors, it's not just displays, of the whole ecosystem is moving to always create the next better product. And 8K is just kind of the natural next level that folks will be aspiring to. So let's talk about the content creation a bit. So there are a bunch of benefits when we talk about 8K capture. And I'm talking just capture, not finishing and distributing at this point. So that big canvas that I showed you earlier creates a lot of opportunities. If you're looking at the entire sports field, for example, you can create cutouts, moving windows that can be tracked to a player or a ball. And those can be direct to air, which is a big benefit and can potentially eliminate some camera positions. That's the reframing and region of interest kind of application. You can also do kind of pan and scan within that, even if it's a file-based workflow. So you can, you know, zoom in and move around the image in a bigger canvas for a finished lower resolution product. If you finish in these lower resolutions, it creates a lower noise image. And it's just better deliverables. It's well known that oversampling or capturing in 8K and finishing in 4K or 2K delivers a better image. And on the commercial side, you can also use that 8K camera to eliminate a digital still camera, a photographer on some commercial shoots, because those frame grabs are not good enough for print photography, for example. It helps with special effects. You've got more pixels, better edges, better plates can be created, better insertion of special effects. And obviously, future-proofing is the most important thing here. If this is a high-value piece of content or a live event, you want to have a highest quality archive available. And studios have kind of learned that the hard way in the 4K revolution, because they had to go back and rescan, and now they're going to go back and rescan as 8K becomes more feasible. So just go to 8K in the beginning. So here's this region of interest application I talked about. This happened to be for a concert. So you can now switch between all 4 of these images with one camera, which before would have taken maybe 4 cameras. And by the way, this software and hardware is available from multiple vendors, so very feasible to use this. There's lots of 8K cameras out there. Displays and cameras typically lead these resolution transitions. So cinema grade cameras from a bunch of folks. There are 12K cameras from Blackmagic Design, and even a 4x3 17K camera for IMAX type capture now. Broadcast quality cameras out there available from multiple vendors. This has been spearheaded by NHK, who's been broadcasting in 8K for over 2 years now. Did you know that? Yep. We're going to see some consumer level cameras. Let's call them prosumer level cameras. Those would probably be in the $4,000 to $6,000 price range. And smartphones already have 8K cameras embedded in them. The high-end Samsung phones, you can capture 8K 24 frame content today. Put that up on your 8K TVs. That's quite an experience, and I think going to be one of the important drivers for 8K TV adoption, this user-generated content. So as I mentioned, the NHK has been broadcasting for 2 years. The Olympics was going to be a big premier event for 8K from last year's event. That was postponed, obviously. I hope we'll see that this summer. And then we've got other Olympic events coming up in the World Cup. I suspect these are going to be high-profile 8K events as well. We've seen other trials and demos for other mostly sporting events to date. COVID-19 has delayed those. I hope those will start up again soon. And did you know that a lot of movies and TV productions are already captured in 8K? And that's because of all those benefits I described previously. These people understand the benefits of super sampling. And so we just have to encourage more content to be finished in 8K so it can be distributed in 8K coming down the road. Film-based content can clearly be scanned in 8K, and there are now even 12K scanners out there right now. I think that has more value for 65mm film than 35mm film, but lots of content out there that can be converted to 8K. And up conversion is always possible from lower resolution cameras, and that's part of the production workflow on both live and file-based. There is plenty of equipment out there. NHK primed the market with their Japanese suppliers. If there are some pain points to adopting an 8K workflow, there's no doubt. More processing power, more memory and storage, transport and bandwidth become larger and of concern. But these were the same concerns when 4K was introduced 6-7 years ago. Those pain points were overcome in the file-based workflow system because a lot of streamers offer that, less so on the broadcast side. But history the situation today is much different than it was for 4K transition. The move to cloud infrastructure and cloud processing and remote production has been greatly accelerated due to the pandemic. The advent of AI and neural networks was not around when in any significant way when 4K was coming in. That's going to impact workflows significantly, improve technologies significantly. And the business models are different now. The broadcasters are moving to the IP, to the networks and IP distribution. So I think all the factors are aligning very nicely to help 8K become adopted much more easily than people think at this point. So in summary, I think we have clear benefits for 8K capture and remastering. There's a lot of things going on in the 8K production workflows. It's very similar to 4K, and I think we need to talk about that a lot more from the 8K Association. And the pain points are going to be addressed, I think, fairly rapidly and are being addressed rapidly. On the distribution side, it's a different ball game now than it was for 8K, for 4K as well. We've got lots of codecs in the market today and coming to the market. This was not the case with 4K, so there's a lot more to choose from, which means it's easier to optimize some of these codecs for specific use cases like 8K. And with the changes in the market I just described, with moving to the cloud, virtualization of production, and AI and neural networks, this technology is also being applied to codec development and encoder development to reduce bit rates and reduce costs and create cost-effective capabilities for 8K. So this is coming. So today, NHK is using HEVC at 80 to 100 megabits. That's not going to be a commercial solution, and that's why we're seeing all this innovation in codecs and encoder development. So I think in the near term, we'll see some of these codecs like LC, EVC, HEVC, and AV1 start to stream 8K content. Later, you'll see these other codecs coming in, which make further improvements in encoding efficiency and bit rates. But there's also this very interesting thing called smart or AI-assisted streaming. And what we mean by that is that we start with an 8K master. We now smartly down to 4K, capturing how it was down converted with metadata. Again, we're probably going to be using neural networks or AI to do this downscaling and capture this metadata. You now can stream 4K out to a consumer with this metadata in conventional 4K streaming data rates. A 4K TV will ignore the metadata and see a nice 4K image, which came from an 8K master. And then an 8K TV will use this metadata to restore the 8K image, and theoretically that should be pretty close to native 8K streaming in an 8K format. So we're seeing multiple players doing this. Samsung, Sharp, Fujitsu, and Harmonic have showed variations of this, and that's one of the activities on the 8K Association, is to try and develop an open standard around this concept here, so that will allow innovation on the down-resing and the up-resing for various companies. So there are a bunch of there's not a good name for this, is what I'm trying to say. Start streaming, content aware, adaptive encoding, AI assisted, and this means different things to different people. So we're trying to facilitate the conversation around this and move to an open standard. So we think smart streaming could be significant for reducing the data rates to conventional levels to enable streaming service in the near term. These new codecs are coming on board, which will also help, and improved codecs are coming in the next 3 years as well. We're not as up on satellite and over-the-air distribution. 5G is probably overhyped for consumer adoption. It's probably going to be important on the distribution side or the production side, where millimeter wave can be more readily adapted in that application. For consumer delivery, however, I think cable networks and IP distribution is going to be the primary route for 8K adoption. There is an app out there from the Explorers, which works on a Samsung TV to deliver 8K content today. I think we'll probably see more of those this year, and maybe 2 or 3 years we'll see the major streamers jumping in. Just my guess. 8K playback. I think an 8K Blu-ray disc format is unlikely. I think streaming is the future here. Maybe there could be a USB-based solution. Think Redbox, but with a USB stick and with 8K content on it. You pick up at your pharmacy or grocery store. There are no set-top boxes or USB streaming sticks that support 8K yet. But the good news is the chipsets are out there to support 8K streaming, so we just have to wait for someone to pull the trigger on that. There are AVRs out there that support 8K pass-through and 8K upscaling. And the two new console boxes, PS5 and Xbox Series 10, do not support 8K today, but my understanding is that firmware updates will allow that to happen sometime later this year. So how do we get 8K in an uncompressed format over a cable from some device to the TV? Well, I've highlighted in yellow here the most common video format, which is 8K 60 frames per second, 10-bit with a 420 color sampling. That's 30 gigabits per second. So that's a lot of data. But here are some wired connectors that can actually support that. So HDMI 2.1, DisplayPort, Thunderbolt, and USB can all support this potentially with different combinations of DSC or alt mode configurations. So not a problem right now. What about Wi-Fi? Well, Wi-Fi 6 is kind of the latest devices that are out there, and they are available today. They use the same gigahertz bands, but they increase speed and importantly enable bonding of multiple channels. So if you need more bandwidth to support that 8K signal, you can bond it. And there's been also a new 6 gigahertz band that's been approved by the FCC here in the US that will add even more speed and capacity going forward. So we don't see this as a problem for 8K. Moving to displays, I think the key point I want to make here is in AI upscaling. The fact of the matter is there's not going to be a lot of native 8K content out there today or probably in the near term. So upscaling is going to be an important way to get value for an 8K TV. And the upscaling technology today is quite different than what it was in the 4K transition even just a few years ago. It's AI based today. So the previous ways to upscale it was more kind of nearest neighbor or simple algorithms like bicubic. But now all the 8K TVs use machine learning and neural networks to do this kind of image restoration or upscaling. These algorithms, I think, are very good for 4K, and as you get to lower resolution contents, the fidelity decreases clearly, but can still make improve that image on the 8K TV. There's no doubt about it. And this is, I think, is going to be one of the key differentiators for different 8K TV manufacturers is how good their upscaling technology is. And just as a reference point, the new Samsung TVs start with an initial neural network that analyzes the content that's coming in, the frame rate, the resolution, the image quality, the artifacts, etc. And based on that, it can then send that to one of 16 optimized neural networks based on the characteristics identified in that initial neural network. That's getting pretty sophisticated. And now it's going to improve this restoration capability for lower resolution content, I think. So very important area and a value proposition for 8K TVs. So 8K TVs are clearly the main product that's out there today. Dell does offer an 8K monitor. Maybe we'll see some others coming to market this year or next. VR headsets, that content's already distributed in an 8K container. It's not a traditional raster format, but Apple has been rumored to be thinking about putting 8K displays per eye. So interesting, how are you going to distribute that content now? In digital signage, there are clearly very large LED canvases out there with way more than 8K resolution. So the developers of that content, they want 8K capture. There's no doubt about it, because if they have lower resolution content, it's too much upscaling. So you got to start with higher fidelity input, right? Laptops, maybe we'll see an 8K. Phones, probably not. TV technology, LCD 8Ks are available from 55 to 120 inch with a whole range of image quality here. Most of them are going to have in the higher end here. So dual cell has millions of zones, mini LED thousands of zones. And I think the big takeaway from CES this year is the new emphasis by the major brands on these mini LED backlights. And so you will see 8K TVs from these brands with thousands of zones with performance that's probably getting close now to OLED in terms of reduction of haloing and black levels, but with the added benefit of much higher brightness. OLED 8K TVs are available, micro LED TVs, displays, and I guess they're TVs at this point because they have tuners and a lot of the same TV interfaces. Much bigger sizes, much more expensive. And there's other display technologies in development I think most of you are aware of as well. And we will see those offered in 8K technologies, I'm sure. So in summary, we've got major brands offering 8K TVs today. That will continue in the future. Rollout will of course vary by region. I think a big driver here is going to be the 10.5G fabs that are out there, primarily in China. There's a lot of capacity there, and they're optimized for 65 and 75 inch sizes. So that will drive adoption because you want to keep those fabs humming and fully utilized. And it's very similar to what we saw with 4K and the 55 inch panels that were optimized for the big G 8.5 fab capacity at the time. So I think history is going to repeat here. But nonetheless, 8K remains kind of the pinnacle of TV manufacturers' offerings, and we'll see that the market continue to be invigorated by these new technologies. So it's exciting times in display technology. I think most of you would agree. So that was my quick summary of the 8K ecosystem. Let me shift gears and talk about the light field and holographic ecosystem. So again, we'll start with production. So the whole idea here is that there's kind of two parts here. There's camera-based capture, and then there's synthetic image generation. And on the camera side, there's lots of configurations of way you can capture light field images. And light field images, my definition is the ability to capture the fidelity of images in multiple dimensions. So you can move your head around an object, you can rotate an object, and the rays from that object will be represented in the different views or different angles of the object. So the textures change, the way the object reflects light changes as you move this. It's a capture of a 3D environment from multiple perspectives. So that's an important way of looking at it. So the volumetric video capture, where you have a studio with literally cameras surrounding a performer or an object. You can have spinning rigs of cameras. You can have literally big balls of cameras with outward looking, popular for VR. You can have 1D and 2D arrays of cameras and planoptic cameras. Planoptic cameras are larger sensors that put a micro lens array in front of them to capture light from different angles from the scene. So here's kind of some images of this. Here is this volumetric light field stage. Here's a 2D array of cameras. Here's this spinning rig of cameras. This was a Google innovation. And this is another capture rig here, capture studio. Switching to the synthetic content side, these are all computer generated. So think of game engines and games essentially generated in the Unity or the Unreal game engine, and special effects capture tools as well. And the level of sophistication in synthetic content generation varies widely. And you have to add more and more elements to this to start to get to the point where it looks lifelike, and that clearly is the goal here. So physics engines, skeletal models, ray tracing, materials properties that are very, very sophisticated, that can react to light differently by wavelength, intensity, and angle. So these are very complex models, and not all pieces of content will use all these elements. But clearly, at the goal is to try and develop these capabilities so it becomes more lifelike and has that ability to look around and in and out. So what is needed? Well, we need a standard representation of this immersive media. We've got all of these elements to bring together, both on the natural, the video capture side, as well as the synthetic side here. So it's not only the visual part here. We have to also think about audio. We have to think about haptics. We have to think about interactivity of various sorts. And this has to be bi-directional, right? It has to go up and down the network. We also need to think about what the default display is going to be. In conventional media mastering, we have a display in mind when we do it. When we make a movie, we have a cinema that we're mastering to. When we do the home rendering, we have a display in mind that we're going to be doing this to. We don't know what the default light field display is going to be, so that's important when we make rendering decisions. Digital rights management, security considerations, metadata, all has to be part of this immersive media package, if you will. So on the distribution side, we got a bunch of challenges here. So think about those big ball of cameras, those linear array of cameras, a 2D array of cameras. We're talking, dozens to potentially 100 cameras. Those are huge data rates. How do you get that over a network? How do you render that? How do you compress it? Same thing goes with the synthetic images. There's lots of tools and features that you can add to this, and you can potentially start to mix it with these camera images. Where do you render this now? Once you have all this immersive content, do you render this in the cloud? Do you render this at the edge? And where exactly is the edge? Is it in your neighborhood? Is it in your home? If you have interactivity with this, where latency is an issue, so maybe it makes sense to render this, in your neighborhood or in your home. These are all unanswered questions. And how do you represent all this stuff is all unanswered questions at this point. So MPEG has formed this group, an ad hoc group. It's called MPEG-I Explore group, and I'm a member of this group, and we're trying to study the immersive displays. We're trying to identify the requirements for both MPEG and other standards development organizations. And we'll share this with other organizations and the public. These will be public documents. The goal is to try and make some recommendations for a distribution architecture for considering both the visual and the audio media, the ingest format, the interactivity, lots of stuff to go on with here. If you're interested in this area, we'd be very thrilled if you would join the discussions that we're having. They're very interesting. You may find them. I hope you find them so, and we'll be interested in joining. So what we've learned so far, we need to be display agnostic in whatever approach we have. I mentioned the open standard for the 8K smart streaming application. We kind of need that also in this light field streaming thing. We need a container that's open and agnostic and allows you to put whatever you need to into it and take whatever you need out of it. And it has to work for video capture. It has to work for synthetic content. It has to be able to look at volumetric media formats as well. It should have some stream-based, scene-based representation. So one of the things that we're thinking about, if you have an array of cameras, let's say around a sports field, or a 2D array of cameras, sending that down the network is going to be difficult. So people are already starting to look at how you take those cameras, create a 3D model of what they're looking at, and then put textures and representations, in other words, put it into triangles with textures on top of that, and send that down the network and allow the display to render that representation. So it basically turns it into synthetic media. And people have already done that. So that may be the way that this goes in the future, but in the short term, we probably have to have a way to distribute, camera images as well. And how to compress that is a big question mark at this point. There is some activity in MPEG looking at that already, but I think we need to do more, and that's part of what this ad hoc work group needs to look at. So there is a separate organization called IDEA, the Immersive Digital Experiences Alliance, and they have proposed this container approach, this ITMMF. And the idea here is it is a container that allows you to put in all these elements, computer graphics, volumetric data, light field array images and data, as well as computational photography information into this format. It's a standardized format with a whole bunch of compartments, if you will, for all this data to go into in an organized way that allows it now to be streamed or distributed over a network. And then at the display, it basically it looks at this ITMF format, this container, and it pulls out exactly what it needs for that particular display. If it's a full holographic or light field display, it may want to pull everything out of that ITMF and create that visual image. If it's a head-mounted display that only needs a stereoscopic image, it only pulls out 2 views. If it's a 2D display, it only pulls out 1 view out of this container. So that's the idea behind this, and the IDEA organization is proposing this to MPEG and others as a potential solution here. So immersive displays. Thanks to Pete Luday at Mission Rock Digital for putting this together. He kind of divides this into 3 categories. Points you can think of as conventional kinds of pixels, where the light that comes out of that pixel does not change with angle. So it's a traditional 2D display, or it could be a multiplanar display, or even a volumetric display that emits light spherically, for example. It doesn't change with angle. Rays are displays that form real points of light outside of the display, so it will create an image, a real image in front of the display. And examples here are lenticular, parallax barrier, and light field. And waves now use interference of wavefronts to create an image using coherent or semi-coherent light sources. And most of the devices that I've seen use spatial light modulators to do that, but they drive these spatial light modulators with not with a raster pattern, but with a diffraction pattern. So here's just a diagram kind of showing this idea. So light field displays fall into the rays category. And light field is a term that's been misused, as well as the holographic term has been misused. But there's kind of 2 display categories, if you will. The ones that use light flat panels with some kind of an optical layer or mechanism to steer the light. And the other uses arrays of projectors and a light steering screen of some sort. Again, there's lots of detail behind these that I don't have time to get into. I'll just name some of these companies that are doing ray-based displays. Demenco has an eye-tracked 2-view horizontal only parallax display. Sony has something very similar. Mercedes for an auto display has developed a switchable parallax barrier. with horizontal and vertical parallax. Interesting. Leia, you may have heard of. They had a display in a red phone, which has now been discontinued, but they're now back to working on a tablet display, which will be 2-view in both horizontal and vertical. Stepping up in fidelity, you've got the looking glass display which is 45-view horizontal only. Lightfield Labs is tiling flat panel displays with horizontal and vertical parallax. Weve 3D doing a similar approach, tiled flat panels. Avalon Holographics now switches to a projector array for horizontal and vertical parallax. But Third Dimension Technology and Holographica use projectors also, but for horizontal only parallax. There's actually a company called FYR, Fryer, I guess is how you pronounce that, tiling flat panels for an HMD light field application. And LG Electronics, you may have seen at SID, I think it was 2 years ago, they had a cylindrical horizontal display. So Pete Luday from Mission Rock also had a really nice way of kind of looking at the fidelity of these displays. You know, it's much more difficult to talk about the fidelity of a light field display or a holographic display because you can't just count pixels and, you know, determine the fidelity. There's way too much going on here. So he's come up with an idea of ray density of a way of assessing fidelity. And you can see we've got 4 different examples of ray fidelity going from 3,000 rays per centimeter squared all the way up to 1 million rays per centimeter squared. And you can see the difference between these for sure. And I've seen all these displays. Does this metric correlate well with our perception of fidelity? It's a hard judgment, but at least this is a good starting step to start to understand how you would evaluate the fidelity of a light field display. Moving now to holographic displays. Now these are in the wave-based category, and you know, one thing again in this misuse category here, the Pepper's Ghost is basically a 2D display with a Mylar 45-degree beam splitter. And people call that a holographic display, not even close to a holographic display. So as I mentioned before, real holographic displays write a diffraction pattern to a display, typically a spatial light modulator fabricated with a special liquid crystal on silicon or LCOS display. And it's illuminated now with lasers or superluminous LEDs, which are narrow bandwidth LEDs. Some companies, there's a few companies that I'm aware of listed here. Vivaq using a SLM for a head-mounted display. Envisix is using one for a HUD, an automotive head-up display. iMac is making a new spatial light modulator with 0.5 micron pixels. Most of the LCOS spatial light modulators I'm aware of are, you know, the best is around 2 or 3 microns. So this is a pretty interesting activity. C-Real has a SLM with eye tracking, and C-Real, and pronounced the same, uses pinhole viewing to create their holographic display. So that's my very quick summary of those 2 ecosystems. If you want to contact me more about what the 8K Association is doing, here's my contact information. If you're interested in joining us in the MPEG iExplore, please reach out to me or Arian Hines at Tencent, and she can help you. So that is all I have for today. Thank you very much for your kind attention, and have a good day.